Ah. So, guys, what is tomorrow's topic? I think everyone is excited for tomorrow's. It is for the reason you guys have joined this course, AI. But to understand that piece of knowledge, you require a lot of things. Yes? Yep, yep. So, what you guys are working on? Anyone can tell me any new project you guys are working on? And a new project? I am Java developer. Happy to be studying under you. Big thanks. Thank you very much, Manoj. Sir, will you teach complete machine learning module? Rahul, some mentor is outside, and once that mentor will come, that my part will be over in that day. All right. So right now we have less availability because I have to start a new batch also. So I'm working on Chase Bank ATM project. That's good. I'm working on agentic. Okay. So for people who are working with agentic AI project, do you think with respect to code, logic and concept, agentic is simple or the part which we are learning is simple? From my point of view, machine learning is much more complex than agentic. Agentic is very simple. Agentic does not require you to understand NLP concepts. Everything is handled by the framework itself. All you need to do is what you are trying to do with that particular piece of framework. How many of you can agree with that? What knowledge you need to be agentic? You need a little bit of confidence and how LLMs work, prompt engineering, and other things. You will be fine. From my point of view, if you understand Python object-oriented programming, good, and you have attended multi-threading and multi-processing class, then async IO will be simpler to understand. So only few things are required for agentic AI. It's kind of a plugin. Yes, it's kind of a plugin. All you need to do is you need to understand how framework is working. And once you understand, because each framework does things little differently, but all of them uses what? All of them uses large language model. So it's up to you what you want to build with that. But it is pretty cool, but not too complex what we're going to do. Machine learning, deep learning, all the part till which we have done till now, the stats and EDA feature engineering, these are the more complex part of our AI. All right. RAG versus agentic AI, both are very different. Now there is agentic AI which uses RAG. Thanks, sir. In my organization, agentic is much and must needed. Soon covering too. That's great. All right. Are we ready? Python helped me a lot. Not my managers wants to work as your manager wants to work as a developer. That's great. I think every manager should do coding now because we don't know which thing we will learn first. Mm, how are you? I'm doing good. All right, guys, let's start the class. Okay. This is my open position for my organization, my team as well. I guess I had discussed this one. Yes, you have discussed, but I needed few more information. I think this is the information, Alok, right? Yes. I have started taking interviews, latest three, one interviews of IIT and NITs, and one of the US university, one from Amazon. All right. Wells Fargo. All right. All 8+ experience, but I can say each one lacked good knowledge and could not clear interviews. All right. I can say your students feel like Sudhir Shiva sound really good. All right. Maybe you can put a word, Alok, at the end of the class. What is your requirement again, so that people who watch the recording will also get to know. All right. And if you have some kind of a form or something, then you can also check that. Let me write that in a notepad. Where is that? Guys, give me a second, okay? Thank you very much, Alok. And guys, people are giving you opportunity, whether you are ready or not. Yes, Manoj, I will discuss the topic. All right, let's me share the screen. And guys, what is today's topic? Yes, Viren. Alok will share. Shiv, yes, Alok will share. Don't worry. I will provide the link. We'll do something. 29, 2025. All right. Manoj, that is in the syllabus. I cannot talk about the overall topic. Okay. Everyone, so today's agenda is last class of EDA. EDA 2. Yes. In the previous class in EDA 1, if I say in EDA 1, I have covered what data set? What was the data set I was using in EDA 1? Guys, you remember or not? What was the data set I was using in EDA 1? Cancer? Guys, diabetes. EDA movie. See this. Movie sentiment was the first one. Movie. Okay. Movie sentiment. This is already completed. Half part I will complete today. No, sir. Movie was second. No, guys. Feature engineering, I was teaching with house price data set. That was feature engineering module. In the EDA, we have only covered movie sentiment. All right. Now, EDA 2. I will cover movie sentiment 2, which will only take half an hour because we have covered the majority part. So I will talk about movie sentiment 2. Then I will talk about two more EDA. I have only confirmed in the previous class only one, but this time I will do two, but I will not do all the EDA possible. I will only do the important one, which will give us the relevant information. All right. So I will be talking about another data set, that is wine quality. You will see lot of data science project, machine learning project on this particular data set. So this is pretty common. How many of you have seen it? Chris sir used it in YouTube, and lot of the mentors use this for the machine learning. Wine quality, it's a good data set. How many of you have seen that wine quality data set? Or you guys are not doing the homework? I saw. Great, Shara. Okay. Guys, please invest more time other than what we are teaching in the course. I have seen, that's great. Great. And the last one is commodity data. This one in the syllabus, you might have seen in the name of forecasting. But as we have not done the forecasting, this data set is used for forecasting. But we are in the EDA phase, so we cannot do the forecasting. But what we will do, we will do EDA on this data. All right. Are we clear what we are going to do today? And by this, we will complete the EDA. Other data set which are available, like the movie review and others, those are pretty simple data set. All you can do is you guys can do simple EDA on top of that and you will find. But whatever EDA you require, you will be able to understand all of them here. Movie sentiment is of which type? Movie sentiment data is of which type? Textual data. Yes. Wine quality is fully numerical data set. Numerical. And this one contains date. It contains date. It contains numerical data. And it also contains missing values. When we have missing values, what we do with the data? Guys, when we have missing values, what we do with the data? Whenever we have missing values, we do handle the missing values. Imputation is one of the technique, imputation with mean and others. Yes, we do the imputation, but what do we call? We handle the missing values, right? Resample, resample is good, but resample is for different purpose, Sridhar. All right. Is everyone clear what we're going to do today? Yes, great. How many of you are excited? Excited for today's class? All right. Great. Great. Okay. Don't worry. It will be simpler because we are not going to do any new techniques like NLP and other things because all the things we already know. All right. So let me start with what we have already done. I'm just going to run all the cells till this part. That is once in this one, guys, what do we call this one? Word cloud. Yes. You remember? This is word cloud. Okay. So selecting the Python base. I think this week I have seen less LinkedIn post. Less LinkedIn post. You guys told me that you will be doing that, but you guys are waiting for perfection. And keep this in mind, perfection will kill your progress. I was in your shoes and I did my side of, what should I say? All right. Okay. I have my notes ready. Let's run each and everything. Oh, I think running few things will take time. Okay. Sure, Zulkan. I will say Zulk. Okay. This part is done. Okay. So next part, guys, as I mentioned, EDA has two parts. What are the two different kinds of EDA we do? Everyone, what are the two different kinds of EDA we do? Descriptive, Ranga is saying descriptive and inferential. Correct. All right. Descriptive and inferential. How many of you know what do we do in descriptive? Summary, plots, visualization. Yes. Mean, median, mode, summary. Central tendency, variational trend tendency. Yes or no? All of that we do in descriptive. If you don't know what we do in descriptive, please watch the previous class. But whatever is relevant to this one, I am going to write it here in the inferential one. Okay. Now in the inferential, okay, it is in the inferential, we ask question like, let me zoom in like this. In the inferential, we ask question like, can we claim this effect exists? Okay. Can we claim this effect exists in the larger population, or is it just a chance? In the previous class, I have told you what does this mean? What does this mean? If I talk about what are the tools of inferential, guys, what was the tool of inferential? Correct, Shiv. Only few people are learning. Hypothesis testing, and we use confidence interval. Okay. And regression based inference, which we do, but we will focus on hypothesis testing. All right. In real world, we usually don't go till this level to understand more about can we claim some data or not. All we have is data, try to understand and create a model. And when we are trying to understand the data, it comes under inferential or it comes under descriptive. Tell me, if I want to understand the data and remove few things, whatever I require and don't require, and then create a machine learning model, it comes under descriptive. I am not trying to prove something here. That comes under the data analysis part. If some company wants me to test about the data itself, but usually we don't go to the inferential part. Even if you're going to the inferential part, we go to the regression based inference or we directly jump into the machine learning. So majority of the things you guys have to focus on the descriptive part. All right. Is everyone clear? Which EDA you guys should focus more? To understand why of certain things, we will go to the descriptive EDA. Is everyone clear? Only 2-3 people are interested. Is everyone clear? Great. Okay. So I'm going to mark this that this is what we are going to use. Okay. So the first thing what I will be checking is that because we already know about the data. Okay. We already know about the data. I am going to write what statistics we are in. We are doing inferential stats. Yes, ML descriptive data analysis, inferential. Data analysis. No, look, that is not looking correct. ML should not be descriptive. ML is a different part, but EDA has descriptive and inferential. Okay, how we do the analysis, what analysis we are doing depends on that. Whether we are doing the analysis, whether some data belongs to some category or data is even correct or shows whatever the data pattern we are getting is random or not random. That part is inferential. But getting the summary where this is a mean, median, mode, this is what my data looks like, this is the behavior of the data, that is descriptive. Will correlation between features part, guys, tell me, this is a good question. Correlation between features is a part of descriptive or inferential? Correlation. Correlation is descriptive. Correlation does not care. See, guys, this is the question. In descriptive, in inferential, we ask this. Do we have the same question in confusion matrix, in covariance matrix, in correlation matrix? Do we ask this question? No. So whenever we ask some conclusion about a population, okay, conclusion about some population based on the current event or whatever the event, comparing with some event based on the population, then we are going with the inference one. All right, clear? Shiv, Alok, everyone? Great. Okay. All right. So first one, guys, everything is just going to be a module based. All we need to do is how to understand what the output is. Okay. So first of all, I'm going to write our goal. I'm going to write multiple goals and using multiple hypothesis testing. So goal one, what I want to do is check if review length differs significantly. Okay. Check if review length, just let me minimize this one. Better. Okay. So what we want to do, check, let me write. Check if review length differs significantly between positive and negative reviews. Yes, this can be one of the check, everyone. So tell me a few things which we can do. Tell me what are the options in your mind you are able to understand, you are able to solve. What is the solution you will go with? If you want to check if review length differs significantly between positive and negative, what are the first things which you guys will do? Forget about inferential, forget about descriptive. Just your understanding of stats, what you guys will do. Suppose I'm also writing this code. I have sentiment positive, review word length, sentiment negative, review word length. So here I will have positive lengths, here I will have negative lengths. So what you guys will do? From these two metrics, I want to check, I want to review this, whether there is a significant difference between positive and negative review. Correct, Ashish? No, you guys are thinking too hard. Yes, correct, Ashish. We can also say that, but that might be too much. Because of the outlier, that can be vary a lot. Yes, everyone see this. If I check the mean of both the pos lengths and negative lengths, I might, if both the means are kind of the same, after removing the outlier, can I also say that it is not significantly different? That can also be one of the metric. Also, because mean might be impacted by some number, if I do the median and the median of two also closer, can I also conclude the same with a very, very simple metric? These are two very simple metric. Guys, are you able to understand? You guys have to run your mind. Everyone has completed statistics. Two things: mean, how the numbers work. Very simple. All right. So let's do that. So what we will do, calculate the mean of positive lengths, mean of negative lengths. We will check how difference they are. Then we will check the median also, because mean might not tell us the two things. But if both the mean and median are saying the same thing, that they both are not different, then statistically, without using inferential statistics, we are able to understand that. Let's see. This one is doing nothing but mean words positive, mean words negative. I'm using this two only. All right. Then mean words positive, median words negative. Done. Now tell me from these two, do they differ too much, negative and positive? No. See this. Read it. Not much, guys. This two words length is not. Here we are getting two words length. Here we are getting around three words length. It is not too big. If it is 232 and this one is 432, then there might be a difference. Are you guys able to understand this? Everyone? Yes? Great. Okay. So this is what we are able to conclude, and this is inferential or this is descriptive. Inferential or descriptive? Tell me. This is descriptive. All right. So I just wanted to compare and then show you when to trust, when to not trust. We as a data scientist, machine learning engineer, statistician has to do a lot more things. We cannot just rely on a single thing. This is simple. We are able to conclude it very, very, very easily. We don't have to do anything else. But because we are in inferential, now I will talk about the other part. So there is something called as two sample hypothesis test. Okay. It is called as independent sample t-test. Guys, as I mentioned, there are multiple kind of hypothesis testing. Okay. Some are chi-square, some are t-test, some are z-test, and there are a lot more. Yes. There is something called as two sample hypothesis test. We just need to provide the positive length, negative length, and then it will provide us how difference they are. Whether if they are too much difference, then the p-value will be higher. If they are too much smaller, then p-value will tell just reject the H0. Same concept. Is everyone able to understand? Same thing that every test follows. H0 we will mention, H1 we will mention, and if p-value is smaller than some value, then we will say we reject the H0. If it is greater, we fail to reject H0. Is this part clear? I'm not even talking about method. I'm talking about how we do hypothesis testing. Great. All right. So what I'm going to do, I am going to import something called this t-test. How do we know, Ranga? This one is a fancy one, but because we know chi-square, I will also show this with the chi-square. Chi-square is used for everyone categorical data. Okay, so I will tell where do we need categorical data. So chi-square we are familiar with. This is just a fancy way. You guys can later learn more about it. All right. All right. Yes. So we are using one kind of a hypothesis testing called as, let me just write it. This is called as two sample hypothesis test. That's all you need to know right now. Okay. Then what we're going to do in this two test, we are going to pass our pause length and negative length. See this. Here I'm writing. Perform independent sample t-test. We are going to do independently for pause length, and then we are going to have this comparison of pause and negative. And then we are going to get t-stat and p-value. That's all we need to know. But the p-value concept is always same. We are comparing two independent things. Guys, these two are independent, yes or no? Yes or no? Positive length is independent, negative length is independent. We are just passing it and then it will check. It will do this testing. All right. So, okay. I will also write the case that in which cases we use this kind of test. Okay. So here we want to compare two independent groups, positive length and negative. They are not dependent. That's what we are saying. They are not dependent. Then reviews can be either positive and negative. That's why there are two groups. All right. There are two groups. A review cannot be both positive and negative. So when we have this certain kind of distinction where a review cannot be both the cases, and we want to compare, we want to have them whether they are different or not. All right, whether they are different or not, then we use two sample. Where is that? The name, yes, let me write it here. Then we use this particular hypothesis testing. Are we clear? When can we use two sample t-test? All right. So that's why it is called as two sample. We are providing two samples of it. It will provide us p-value. Now, how to read the p-value? If the p-value is smaller than 0.05, this particular test itself does what? This particular test itself does what? It is saying that H0, see this everyone. H0 says that average review length in word is same as for positive and negative review. This is what H0 means. It means both of them, whatever we are doing, the independent are same. So H1 will say what? This is H0. It is saying that the average review length of both positive and negative are same. H1 will say what? Not same average. That's all. So let me write H1. Average review length in words is different between positive and negative. So if our finalize, I'm doing the final thing. If our p-value is smaller than 0.05, then if our p-value is smaller than 0.05, then we reject it. No, Gaurav, we are not defining. In this particular t-test, it checks whatever we are providing means they both are same. They both, these two independent identities does not have difference. Gaurav, are you clear? In this particular t-test, the value which we provide, these two independent data which we provide, we are saying in H0 always that they both are same. Are we clear, Gaurav? In this case. All right. So that's why we do that. So now let's print the p-value. Okay. Let's print the p-value. Where is the p-value? Okay. That's now let's see. So our p-value is 0.02 means we reject H0. Yes or no? We reject H0. H0 was saying average review length is same for positive and negative. But here it is saying no, average review length is different. Means average review length is different. This is our conclusion. Yes or no? Now tell me, is this conclusion matching with what we have found with the descriptive? How many of you are thinking that we were able to found that H0 is correct from our descriptive, but this particular test is saying they are different? Yes, the value P 0.027, 0.027 is smaller than 0.05. Means we reject H0. How many of you are able to understand what I'm saying? They both are saying different thing, yes or no? Others, there are a lot of people who are not answering. Yes. Okay. Now tell me what might be the issue. Tell me what can be the issue here. Outlier. Not balanced data set. Okay. Okay. Missing value? No. Guys, you are missing the fundamental point. What was the fundamental point of hypothesis testing? One was skewness is there, then the data will be misleading. They expect data to be in normal distribution, yes or no? Also, one important fundamental, everyone, one important fundamental. Here currently, if I check this df, let's check df.info or df.shape. How many data we have here? Hypothesis testing we do on sample of data, sample set. So if we don't do on sample set, even a minor difference between sentences when there are a lot of them will give us this kind of p-value. Are we clear? See, that's why statistics is important. People who have not learned statistics, I'm not talking about how do we do hypothesis testing. Guys, are we talking about the formula? Anywhere I mention what is the formula, z test, t test, anywhere? No. All we need to do was understand those two statements I mentioned for p-value and few things about hypothesis testing. That's all we need to do statistics, at least the inferential part here. So what we will do now? What we will do now? Say this. Test on whole data? No, we were testing on whole data. We will take sample. So df.sample, I want to take sample of 1000. 1000 is small. 1000 is small. Random state. Guys, 1000 is small as compared to 50,000. As compared to the original. Uh, so what is the issue with the big data set, Shiv? Because it calculates the differences. And if there are differences in lot of data, even the minute differences keeps adding up, then the p-value becomes small. So we always do on sample. Yes, Lalit, we also need to keep normal distribution in mind, but in real world, we cannot do lot of things with normal. It is ideal with normal, but even without normal, we can compare the previous versus the after. Yes, we can compare with the previous and after. All right. So we will get an idea. Little confused. Shouldn't we accept H0 since 0.02 is smaller? No, in this case, when it is smaller than 0.05, then we reject the H0 because probability, the chance of getting that number is very, very, very rare. It means it is significance. Humid, are you able to understand? Humid, guys, this is how we read it. When the value is very small, it is 95% significance, that is 0.05 smaller. How we read it? The chance of getting this value is very rare. It means it is it means it is significance. The chance of getting this value is very rare. Yes or no, guys? How we read it? The chance of getting this difference is very rare. That's why we are rejecting H0. Are you guys all lost? Everyone, I'm saying others. Others. Am I teaching to myself, guys? Understood? That's why we always read it. Great. Okay. This is what I taught in the previous, in the statistics class also. This is how we read it. It is very rare. That's why we reject H0. All right. Now we will take a sample subset. We will do all of these things again. But instead of doing on the subset, we will do on subset. See this. Subset, subset, everything I will replace with subset, and then we will check the comparison. Subset, 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 subset. Our mean should also change now because we're taking the subset. It might not be the ideal one, but let's see. Okay. And let me try. Testing on subset. Is it bigger? Is it bigger? Is this also stating the same thing? Both of them are stating the same thing. Now we fail to reject H0. It means both of them are doing the same thing. Descriptive is also saying the same thing because it is descriptive. There is nothing to like get more information about, right? But now our inferential is also telling the same thing. So always conclude your logic whether something is sound. If suppose someone is telling you do hypothesis testing, you are saying no, they are same. Both of them reviews are same, okay, or different. Here in this case are different. Now someone who does not know the basic stats also how to think about it will say they are different. Positive and negative reviews different, they are different. So we will create a machine learning model. So we will create a machine learning model that above certain threshold, I will say it is negative, else I will say positive. But it is not that different. So we cannot create that simple if and else statement. So we need to prove it. That's how we prove it. Yes, when the p-value is greater than 0.05. When the p-value is greater than 0.05, then what do? We fail to reject H0, the null hypothesis. And null hypothesis is saying what? Null hypothesis saying what? Average review length is same as for positive and negative. Our mean and median are saying the same thing, that they have the same average, negative and positive. Mallikarjun, are we able to understand? When the sample size was 50, we were saying that our average review length is different in positive and negative, but our mean and median are saying no, they are same. But when we reduced our data frame size to 1000 instead of 50,000, now we are saying the same thing. P-value, it means both of them are same. We failed to reject H0. This is also saying the same thing. Everyone, are we able to understand the practical of hypothesis testing? Cool. How many of you have done this kind of EDA before? Tell me frankly, how many of you have done this or seen this ever? The classes are slow, but you will always get quality. Okay. Yes, we should learn new things. All right. Great, great, great. Now, okay. Null hypothesis, can you explain one more time? Yes, Pankaj, see this. Null hypothesis, it is saying whenever we do in this particular case, okay, H0 is saying that both the review length, it means let's suppose for movie, this is H0, Pankaj series. H0 is saying that happy and sad, suppose the review length of happy was 1746 words. Sad was 1748 word. Now, can you create a Python function where you will pass number of words and you can differentiate that if number of words is greater than X, then it means person is happy. Else sad. From this particular logic, do you feel that it is different? Do you feel that there is some differentiating line between happy and sad? Pankaj? No, there is no differentiating line. They are very, very close. So H0 is saying that both happy and sad review length is same. H1 is saying that both happy and sad are of different length. H1 is saying that, let's suppose happy is 1746 word, sad is 40. That is what we call as different. Pankaj, are we clear? What is null hypothesis? Are we clear? So our null, we were saying, where is null? Yes, you're welcome. Our null, we were saying both are same. And H1, that is alternative, we were saying both are different. Now we are also able to conclude that both are same. Both are same. Inferential, differential. Okay, descriptive. I was saying differential. Okay, now if we change our sample data length, then p-value will also change. Yes, guys, if I change this length to 2000, is it still bigger? It is bigger. 40,000. Now it is getting smaller. If I run it again, we might see a different one. Okay, because of the random state. Let me try with 10. Now it is smaller. Small. I change the randomness. Very small. But if I do with the same random set of again 1000, is it very high? It is high. Great. Okay. Next, final one which I will be doing, and this will complete our first EDA. Okay. And hypothesis testing I will show, but the t-test I will show in one of them. Okay. Now we will do chi-square. So guys, chi-square we do in, let me do in Python. Chi-square we do for how to choose sample size, not too big. Small is fine. So Smith, tie with multiples, whether you are able to get the same thing. But guys, what is the one thing which we also learned from this? We cannot always depend on the statistical method. We can always go with the summary statistics also to be able to understand. So not always rely on this one. Always rely on multiples and then conclude it. Is everyone clear? Is everyone clear? Rely on multiples, and the more you will provide, the more confidence you will have on your particular analysis. Always, you are a statistician, never do just mean. Suppose I only chose mean. Mean is showing me around 8 words of different. This one is showing only 2. So always have more stats to be able to conclude your final answer. So we are doing chi-square test of independence. Now tell me, chi-square is done on numerical, categorical. Chi-square is done on categorical. The word length which we have, the word length which we are having to check whether they are different or not, are they categorical? Word length, are they categorical? They are not categorical. So what I will do, because I want to use chi-square to be able to find the difference, and difference I want to find in some other way. Something like gender. Gender is a categorical one. So what should I do with all the things which we know to make this data categorical? To make this data categorical. If I convert sentiment to categorical, positive or negative, this is a categorical one. But sentiment is not a good thing. Sentiment does not tells us the difference between, guys, what is our again H1? What is again our H0 and H1? Same thing. Do you think sentiment falls under this H0 and H1? We are talking about average review length, or whether the review are different or not. That's what we are saying. This time we will say whether positive reviews and negative reviews are different or not. Yes. Yes. So we cannot go with sentiment. Sentiment is one of the category, but it is not the one which we are looking for. So can I convert review length to be either short or long? Yes, can I do that? I can do that. I can do that. So what I'm going to do, see this, very, very simple. What I'm going to do, I'm going to use this sample data set only, df underscore subset, because we already have a subset or sample of 1000. So what I'm going to do, see this, df subset review word length, I'm going to apply. If x is smaller than 100, I'm going to say short. If it is greater, it is long. I can make it 150, 200, it's up to you. Yes, it's up to you. From the median or mean, you can choose either 170, 120, 226, it's up to you. But you are just going to create a differentiating factor, which one is short, which one is long. Are we clear? Yes, correct, Alok. Okay, now that we have this length, adding one more column in data set. Yes, we are adding one more column in the data set. And it will be kind of a categorical, but it does have some kind of feature which is telling it is either short or long. See, we are doing on all, guys. We are not doing on positive or negative. Currently, we are doing on whether it is short or long. This is what we want to do. Suppose here we want to check the review length category. Okay. Okay. Let me do one thing. Subset. Okay. Okay. I will talk about it. Guys, I have done this for all. To check whether positive and negative are different or not, we also need to do this on positive and negative. Yes or no? We have only done the splitting of whether it is short or long. Positive can have short, long. Negative can have short, long. Yes? Guys, are we able to understand yes or no? Okay, now see this. I have shown you one thing in the pandas, that is contingency table. Yes, remember? pt.cross tab. I am going to do cross tab of data frame subset review length categorical, which we created contains short and long. And I want to do create a contingency table with respect to the sentiment. Sentiment is either negative or positive. If I print it, review length cat, for long, it will split into negative and positive. For short, it will split into 51 and 60, negative and positive. We provided this data frame. We provided it with respect to what we need to create this contingency table, and it will create this. In Python and Pandas time, I have shown you something like this. Yes or no? Yes, I have shown you. Some similar kind of thing pivot table does, but it does on different thing. Pivot is different, but this is contingency table. But understand that with respect to sentiment, it is going to count. You can think of that as like frequency. With respect to all the categories of sentiment, all the categories of review length category, it is going to create this kind of a table. Review length cat contains two categories, long, short. Each long contains n number of sentiment. Sentiment only has two types, negative and positive. So long has 439 reviews as negative, 450 reviews as positive. Short has 51 as negative, short has 60 as positive. Clear? Are we clear? Now tell me, are you able to see any big difference here? Is there any big difference between this is a short negative and positive, long negative and positive? Is the difference very big? Is the difference very big? Almost same. Previously we did mean and median. This one is different. This one will fall under again descriptive. This one will fall again under descriptive. Now for chi-square testing, chi-square contingency test, it only needs contingency table as input. All right. It only needs this particular table as input. So also let me import that because I think I've not imported it. Just give me a second. Where is that? Or I have to search it. Just wait, okay? I'm just looking for the main import. Okay, found it. This is the import which we will be using. We'll be passing this contingency table. All right. And then we will use the p-value again. All right. We will use the p-value again. So let me run this and check the p-value. Again, is the p-value saying the same thing, that positive and negative does have difference or no difference? If the value is smaller than 0.05, then it means they are same. No difference. So again, we fail to reject H0. Yes, we again fail to reject the null hypothesis. So difference is there? No, Pankaj. Again, we are rejecting the null hypothesis. In the previous one, we were also rejecting the null hypothesis. This is null. Null was saying that both are same, but we are failed to reject both are same. It means both are same. Are we clear, Pankaj? Everyone, are we clear? So see what level we have done. We have done two. What was the test? We have done t-test, which concludes the same. We have done chi-square test, which says the same. We have done mean, median, which says the same thing. Plus we have compared it visually, not mathematically, and it does the same. Last point, can you please explain? Which one, Pankaj? This one? We again failed to reject the null hypothesis. I said the same thing in here. If our H0 is saying, Pankaj, it is the same thing, same H0, H1 as compared to the previous one. We are doing the same thing. H0 is saying both positive and negative are same. H1 is saying both positive and negative are different. So in which case we reject H0, in which case we accept H0 when our p-value is greater than 0.05. All right. But when our p-value is smaller than 0.05, it means the possibility of getting that event is very rare. So we are rejecting H0. It means review length are different. But in our case, our p-value was not smaller than 0.05. So we fail to reject H0. When we fail to reject H0 means we accept H1. Same thing what I mentioned previously. Okay, same thing. If you want me to conclude that we fail to reject null hypothesis, means H1 is true. All right. P-value. So we did two inferential and also we did in interview. If anyone will ask you whether you have used this in your project, you guys are going to say yes. But p-value is greater. Yes, Pankaj. See this. This rule, Pankaj, you need to remember always. P is smaller than 0.05. We reject H0. Else, we fail to reject H0. Now, Pankaj, read this and try to understand. P-value is not smaller than 0.05. So it will not go to this condition. It will go, we fail to reject H0. Are you clear now? Guys, this is the same exact component in all the hypothesis testing which we are doing. Can you please give sample use case? Mantaj, this is the sample use case. Guys, this is the sample use case. Yes, it means we accept the H0. Mantaj, are you able to understand the use case? Guys, how many of you are not able to understand the use case? Use case, should you have said H0 is true? Yes. Yes, Adiyogi. Guys, we never talk in terms of H1. We always say either we reject H0, we fail to reject H0. Okay? I always mention we reject H0 or we fail to reject H0 because what we consider, everyone, what we consider in hypothesis testing, that H0 is always true. Ayodeji, Ayodeji, are you able to understand? In hypothesis testing, the ground truth is H0 is true. So when we talk about the answer, we always mention either we reject H0 or we fail to reject H0. The above line should say H0 is true. No. KK, are you able to understand? Guys, I'm talking about in terms of how we read statistics. This statement is also 100% true. Whatever you guys are saying, H0 is true. That is the conclusion. But when we start hypothesis testing, just how we say it, okay? When we start hypothesis testing, our ground truth is we are considering H0 is always true. So when H0 is always true, yes, we claim H0 is always true. Then there are two things. We reject H0 or we fail to reject H0. We are a third party, guys. We are in a court, like proven until guilty, right? So it's the same thing. We always say whether we reject it or we fail to reject. That's all we do. But guys, this is not for feature engineering. Mantaj, everyone, in EDA, everyone see this. In EDA, guys, not everything is okay. Let me try. This is very important. Mantaj, glad that you asked it. I always like this question. Okay. Guys, tell me whatever you think. What is the point of EDA? Tell me what is the point of EDA? Whatever comes to your mind, just let me. I will write all of your words. Grasp data. It means understand data. Understand data. How data looks. So again, we are trying to understand data, but with the help of visualization. Correct. Finding trends. Or Ravi said analyzing patterns. Satya said finding trends. Both are same thing. So finding trends slash looking for pattern and also to clean data. So guys, we don't do EDA to clean data. Actually, we can say to perform EDA, we need a clean data. Can we say that? To perform EDA correctly, we require a clean data. We can do basic data. We can do basic EDA to understand which operation which we need to do to handle the cleaning data, to handle missing data. But we mostly do clean data so that we can do EDA. Cleaning also means removing the data, removing the nulls, or imputing whatever is required. Right? Also, we need to find correlation, features that are correlated. Correct. Nasir says which part of data is correlated. Yes. Also, we will check skewness of the data. Yes. Or we can directly say distribution. From the distribution, we can answer whether it is skewed or not. All right. So I will say which features are important. Yes. We will find that in the correlation because we will know the target. All right. Now, everyone, try to understand this one thing. We have learned that this EDA step, that raw data that we have, we perform EDA, then we do feature engineering, then we create machine learning problem. But why are we creating machine learning? Why are we creating machine learning? Why are we creating a model? Is it because we have data? Is it because we have data? Or is it because we have the problem? We were doing all of this problem. We wanted to solve it. Or we were just doing something out of blue without anything to do with that. We are machine learning engineers. We saw data. We are training machine learning model. Is this how we should go? Is this how we should go? Guys, data scientists are also programmers. They are trying to solve some problem. And do you think any problem can be solved with machine learning? Do you think any problem can be solved with machine learning? No. Problems, not all the problems cannot be solved with. If I wanted to create a to-do list, do you think to-do list is a problem statement of machine learning? We are not trying to learn any feature here. We are not trying to learn any feature here. So let's suppose I want to create, my problem statement is separate young versus old people. I have data. I have data. Tell me, I will talk about two steps. Uh, Ankit, we cannot directly activate. It is already expired. It has limit. All right, Ankit. The RAC course had limits. The limits are expired. So maybe you can wait for more time when Chris sir will provide that and the coupon is available from the Udemy. Then only we can provide it, Ankit. Okay. Sorry for that, but like that is not in our control. Everyone, path one. We will take this data, do EDA, do feature engineering, do machine learning. Path 2, take data, do EDA, and then think if ML required. Tell me which path is good for this particular problem statement. Young versus old people, you need to separate. In the data, you have factors like age, income, etc. Now tell me in real world, what do we call as young and age can be, yes, it is with respect to what do we call as young versus old people, but are they differentiable? Yes or no? Can they be easily differentiate? Can we differentiate them? Yes, we can. So by the EDA, let's suppose we know that all the people who were filling forms, we are able to see that there is a trend like this. Histogram is something like this. We have all the people, but again, we see a sharp decline here. If there is a sharp decline or something, we are able to see some pattern. Right now, we don't know the pattern. I'm just giving you one pattern. If we know the pattern from the visualization, will we able to get this X value that if person age is greater than X old, else young? Yes or no? But for this X, do we require machine learning or with the help of data visualization or something, we'll be able to find it? Yes. So for this particular problem statement, path 2 is more optimal. But did we know from the start by looking at the data that path 2 is optimal? Did we know from the start? So EDA no, we don't always do EDA for machine learning. Data scientist is not machine learning engineer. Data scientist is understanding things about data. And if we think, let's suppose we have a hypothesis, I'm not saying H0 as one. Your company people are saying that there must be some feature there that okay, company people are saying that this is a must statement that they mentioned that there is a difference between negative and positive review length. This is the statement your company made, and you, as a data scientist, are trying to say, let's check this particular thing. What we will do? What we will do? Can we use hypothesis testing? Can we use mean median and compare all of that to check whatever company is saying is true or not? Is this real world? Are we talking about machine learning? Now tell me, in machine learning, if this particular statements uh, is wrong. Whatever company is saying the difference is wrong. If the difference were there, it is very easy for machine learning, right? If the difference between negative and positive review are different, that can be one of the feature, and that we can feed to machine learning to create a more robust model. But if there is no differentiation between the length between negative and positive, do we even need to create a feature of negative and positive, or review length, review length, short, long, whatever, based on the problem statement? Do we need to create more feature which uses the review length? Do we need to uses more feature which uses review length? No. How we will conclude that? Can we conclude that with feature engineering? No. Feature engineering is about engineering your columns which you already have. How you will understand this? By EDA. Is everyone able to understand why we are doing all of this EDA? EDA means data analysis. Data analysis means understand this data itself. What is important? What is not important? What we should do? What we should reject? Hypothesis is one of it, but as I mentioned, you can still go with the descriptive one. Even without hypothesis, you will be able to understand it. But if you want to prove it more statistically, then you will go with inferential statistics method. I hope everyone is clear now. This was a long explanation, but this is much required for you to understand why we are even doing EDA. Everyone, yes or no? Are we clear? Are we clear? Are you enjoying today's class, everyone? Yes? Liking it? Great. Okay. Awesome, guys. Things will be awesome. Always the hard part, everyone, for every data scientist. This is the post which I wanted to create on LinkedIn. And before going on break, I will give you break in 5 minutes. Okay. Because a lot of you people are new. Okay. Tell me, everyone, how many of you are facing issue in thinking how to proceed with problem, or how to create programs, how to think logic? How many of you are facing that issue? Me, I am. There are a lot of people. I am facing this issue. That's great. Don't worry. I will talk about it. Everyone, you need to understand this fundamental difference. And a lot of the people get depressed. I was in your shoes once, all right? But now I'm feeling pretty confident. Even though there are a lot of technologies which I don't know, but I'm confident that I can do that by start learning from tomorrow. By tomorrow itself, I can start implementing. I'm facing it, how to look the data when I inference from it. Okay, don't worry. So everyone see this. This is not about how we should reach it, but about what is going on actually with all of us. Okay. So when we start our career, when we start data science, let's suppose we are in year one. When we are in year one, we started learning data science. And if you are expecting that once I complete this course, I can create a product from this particular thing, wrong. How someone, okay, how everyone should proceed in their career is, they should understand that currently I am as a data scientist who is learning in year one. Even though I am a senior, I should expect things like a junior, because I have not seen how other people code. I have not seen how other people code. I have not seen how other people proceed with solving the problem. I have not seen multiple domains. Right now, we are expecting, if Chris sir new video comes out, Chris sir talking about healthcare. Next video, Chris sir talking about machine learning. Now you all feel like machine learning is too much. Again, Chris sir talking about agentic AI. You should not go to that path. Cover machine learning. Once it is done, create something. In the next year, in the data science, whatever you're learning from this course, in the second year, you will still learn data science, but now now your understanding of data science will improve more. We cannot expect ourselves to learn everything in a single go. If many people are doing that, that is very, very, very wrong. You should never expect that. In the third year, your understanding of data science will improve more. So you are not going to revise the same Python class, whatever I am teaching. What you're going to do, you're going to practice this more and more year by year. Is everyone able to understand how this actually works? Everyone? So when I started data science, guys, I'm telling frankly, when I started data science, I completed data science. I didn't know anything about stats. I missed the whole module. I was like, I will never get a job in machine learning. Then I got an opportunity as a freelancing, as I always talk about, in computer vision. Computer vision was always my interest, the specialization, but I don't know how to do things. All I saw was my mentor was showing some library and not even writing code. There was one notebook, everything was running. The whole computer vision, the specialization I'm saying was completed in 2 months. I don't know how to do things. All I know was the main concept. When I got a job as a freelancer, then I start doing research. I'm not saying research in terms of writing research paper, but doing things, how to do things. I did a pretty bad job, but freelancers were happy. I gained some confidence. Then I again got a job, this time full time. I saw other people code. I saw my managers, people who are 7 years experience, 10 years experience, awesome people. They showed me how to do things. Then you will learn something else. But it doesn't mean that in this particular job, you will learn everything which exists in CV. No, you will work on a particular domain. Then you will go to CV and learn something else. So learning is an iterative process, everyone. You will not get ideas from day one. But if you think, sir, I will skip the Python, I don't like object oriented programming, I want to go with agentic AI. I like agentic AI. There are a lot of jobs. You might get a job in agentic AI. You will be surrounded by people who knows agentic AI. But if all the people knows agentic AI and none of them knows data science, will you ever grow? Will you ever grow if you are with someone who does not have the core knowledge or the full end-to-end knowledge about how to create a product? No. So don't expect from yourself. A lot of you are expecting too much from yourself. Don't expect too much. You will keep on improving. Trust me, I am saying 1000% you will keep on improving, but always start with small. Trust the process. It will keep on improving. This data science course will be completed. It will give you, even the course is 100% of completed. This course, with respect to what you build, how you think, is very, very, very different. You need to do how to communicate with people, how to present. I see a lot of people creating LinkedIn post also. If your presentation is not good, no one will ever give you a lead position. How many of the leads can agree with this? If you don't have a presentation skill or how to relate to the problem, how to think about it, you will never get to a lead position. Ravi, Mohit, others are agreeing. So guys, always focus data science you're learning, how you approach the solution. Now ChatGPT can approach the solution. ChatGPT cannot create the whole thing. You need to have that control with you. So once you finish the course, everyone, once you finish the course, your expectation should be get a job as soon as possible. But if job is asking for more, get to a job. Suppose you are a senior in Java. And now you are asking, sir, after completing this data science, I also want to become senior in ML. Is that even possible? Do you have a senior ML knowledge? Tell me. So if you're a senior in Java, all you can do is, sir, I want to join as just ML engineer. Not senior, not junior, ML is fine. But don't go for junior because there are a lot of things, salary and other things. But go for something which requires your current understanding, even though the pay is not correct. But will that pay will always be same? Will that pay will always be same? No. Once you are expert at this stage, you will jump to the next stage and then you will learn more. Guys, trust me, currently, when I am working in my current organization, I get very less learning. Okay, I get very less learning because I am the only one who is doing the things. I don't get to learn from other people. But because I'm teaching, I'm doing a lot of things, I'm creating a lot of projects, I am learning in that way. but you will be learning from a lot of your peers. You will be learning from project, whatever you want to do, that will keep on happening. Guys, are you feeling motivated now? Guys, Ravi, how many of you have seen my recent post regarding non-tech and tech? Regarding non-tech and tech? Satya is saying they have seen. The only difference, see this, only difference between tech and non-tech people is, I am frankly speaking, tech people have little bit understanding of computer science, which for the job perspective, it is only 5% of your knowledge. Computer science degree teach you nothing. Tech people mostly focus on computer science, creating the background and others. They don't have that much communication skills and others problem solving skills based on the individual again. But non-tech people, even if you have speaking skill or communication skill or presentation skill, I will say that is more important than your computer science degree because it is only contributing 5%. But to get a job, I will say communication, presentation skills are like 30% of your interview or the job. So if everyone, guys, I know for non-tech people, it is also hard to get to this particular stage. And just give me a second, okay? I want to erase this two part and then give you what I saw. There are a lot of people I have met throughout my journey where people are from 12th standard, they are senior ML engineer. The class is not over. They are senior ML engineer only from their 12th degree, 12th certificate. So for non-tech people, if this is the point you want to reach, your path might be looking like this. Little slower at the start, but that pace will increase. And for tech people, it might look like something like this. But you should focus on both of them will eventually get there. Both of them are on the same page. So guys, don't bring your non-tech part. I know it is at this particular stage, you might feel that it is a little complicated for tech people also, but they are familiar with tech words. They are not familiar with tech. They are familiar with tech words. You are not familiar with tech words. That's why you're feeling that overwhelming part. But once you reach this stage, it becomes same for both of them. All the non-tech people, you guys can do as much as tech people. I can guarantee that. So don't bring that. Once you bring your non-tech part, your brain will kind of comprehend that and will try to be like, I'm done. I cannot do more. I am non-tech person. I have this understanding. I cannot do more. No, it is the mindset. Problem solving is not only present in tech, it is always present in non-tech also. Is everyone clear? Is everyone clear? Shri, I will explain, but complete few things, okay? So don't say this to yourself. Once your brain started to store that particular sentence, right? How many of you know or do some check some videos on how human brain works? If you keep telling some other way, your human brain creates an easy path. For that easy path, it will always follow, it will always try to walk in that easy path. If you say, I am from non-tech, I cannot do, your brain will always find an excuse for the shortest path. Again, like a neural network. It will always find some optimized way to get the job done. Your job done is, I'm done. I cannot do more. But only when if you start rewiring it, then the main change starts to happen. Okay, your brain internally works that way. It is not a philosophy. This is how your brain works. So try to, it will take some time, but try to overcome that. All right. So guys, timer. And after that, we will cover 2 EDA. It is not long like this one. It will be short, but we will understand the data. Are we clear? Great, great. I've opening for GenAI engineer my organization. If anyone who's okay. Samsul, please try to create that little job description or the email so at least I can paste it in my notebook and then share with my team. Okay. Otherwise, I forgot the names, right? So let me start a timer and 20 minutes. Shiv, I will share the notebook. I'm sharing the notebook now. Okay. Guys, you guys can go on lunch. Once I share the notebook, I will start the timer for myself. All right. Be ready. Good things are coming. Live movie sentiment data analysis done. I've sent it. Not the data you guys have. Same data. Okay. I have shared to host and panelist. See you after break, guys. Okay. Monal, do you recommend watching Crystal ML playlist before tomorrow? See, if you can do that if you have time, else I will be starting from scratch. JD fine tuning large language models, build capable models, and others. Bedrock. Oh, very nice. I have noted down, and it is. And so, how should we reach to you? Can you please write your mail or something? Don't worry, we will not spam you. But okay, thank you very much. All right, this is the second JD which we got. All right, guys. I'm starting the timer. See you after 20 minutes. Right. Hey guys, hello everyone. Are we back? Everyone had dinner, breakfast. So for people who are asking about my LinkedIn ID, you guys can check. This is my LinkedIn ID. Back? All right. Yes. So we have successfully completed the first full EDA. This will be the most complex one which we did because we did a lot of things, right? Everything which is new for us, we completed here. Texture one, this is, I'm not going to write it. It is going to look weird. So this is completed. Okay, so now what I'm going to do, I will be showing you more data. We will be starting EDA 2. It will be very simple EDA because there is not much to do about it. That data set itself is mainly used for directly machine learning. Do few of the feature engineering, then we are good to go. But still, we will understand few more things about it. All right. All right. So let me take that data. The Just wait. Okay. So let me create wine quality analysis dot ipynb. Done. We will close this one, create a markdown, and I've attached the URL here. You guys can also check the URL. I will paste in the chat. Okay, if you guys want to check the same thing. I will open that URL also. You will be able to find the dataset link, click on it, and it will redirect you to this particular page. This is from UCRWin Machine Learning Repository, and there are two data sets are included related to red and white wine samples. All right. I am currently using wine samples. Okay. I am currently taking one, and you're able to see that there are 100 features and 4898 instances. There are no missing values, so we don't have to clean the data, and you're able to see missing values. No, 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 no. All of them are no. What really good thing about this data is all of them are numerical, but if you check fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sugar, free sulfur dioxide, total density, PS sulfate, all of these are features. But if you check the quality is score between 0 to 10. So all the things, this is the content variable. It is a continuous value, how much alcohol content that particular wine is. So it is about a data set about wine and the quality of the wine. And there are a lot of factors which contribute to the quality of the wine, and these are all the factors. When you're creating a wine, it means when they were creating the wine, there were a lot of factors like how much chlorides are present, how much density, what is the pH of that particular to be able to contribute towards the quality. So quality is our target variable, others are features. Is everyone clear? You can check Shiv, try multiples. Okay. Okay, so this is about wine. Someone created wine, they noted down all of these different things and categorized into a different quality. The higher the quality number, the better the quality of that wine is. Okay, so here we are able to see wine equal quality, white CSV, wine quality dot white quality, wine quality red, wine quality white. So I've also given you a different link. That is Kaggle dataset. If you check here, this is about the same data set, same thing. All right, wine quality.csv, and here you are able to see that let's read about this data set. If they have included either a red or a white one. I think here we don't have red or white. I think they have combined it or created only one. Let's check it based on physiochemical test. Fixed. Color is there. Guys, are you able to see any color? There is no color there. Okay. I have taken this data for the analysis. Currently, I am not talking about any color. All I am interested in all these 12 values which are present here. All right. This is the original link. This is the link. This is the data which I am working with. Is everyone clear about the data set? What this data is? All right. So we don't have a lot of things to be able to check what things we can do analysis about. So we will see them on the go, but the main contributing factor toward the analysis is what contributes towards the quality of the wine. Is there any pattern between them? Yes. Is there any pattern between them? And there are a lot of factors which can contribute towards the quality. We will do analysis on that. So I'm going to move the data. Correlation is one of them. Yes, correct. But let me copy it. Okay. Copy. I will paste into data. This is wineqt.csv. Okay. You can download the same and I will also attach in the resource. So let's get started. Okay. It will be short and very simple. So first we are going to import the libraries, pandas, matplotlib and seaborn because we will be plotting a lot of things. So that is done. Select the kernel, connect to the kernel, delete this malware. All right. Now we are going to read this CSV, wine quality qt.csv. What is the basic analysis which we do every time? Every time, what are the set of analysis which we do? Tell me everyone. Correct. df.head to check how the data looks like. This is how the data looks like. ID is there, qualities, you can see quality 565. Yes, next is we can either do df.describe or info. I'm going with df.info and it is saying there are no null values. Total is 1143 total number of rows starting from 0 to 1142. This is 1143 and I can see there are no null values. That means everything is fine. Next is to do describe. Describe will give me for all the numerical columns what is their mean, standard deviation, mean, 25%, 70, max, and other things. All right. So here we are able to see we have different means, we have different minimum value and maximum value. All right. So guys, for the analysis, we are not going to do that. But if all of them have a different range, all of them are numerical, and let's say all of them are important for the wine quality, for the quality target, if all of them are in different range, what is the feature engineering we do? What is the feature engineering we do? We scale the data. Yes. In this particular case, min-max scaling is also fine because all of them will be scaled to 0 to 1. Yes. Everyone, we can do that. But for the analysis, we don't want to do that particular part. We just want to go with the original data. Great. You guys have learned a lot of things. Now, what I want to see, I want to see the distribution of quality, how the quality is distributed. Okay. How the quality is distributed with the unique values of quality, that is 0 to 10. What I'm going to do, distribution of target variable quality. Let's see that. Analysis. So we are able to see that the lot of the data is present for the quality of 5 and 6. There are less count for 3 and 8. Some are for 4, more are for 7, majority are for 5 and 6. Yes. So we can say 4, 5, 6 are, if we say lower quality, this is higher quality. No, see, we cannot say data imbalance. Currently, data imbalance is with respect to different qualities. All right. But when we collect real world data, guys, if you are a wine company, will you focus on creating the lowest quality wine? Will you focus on creating lowest quality wine? No. You will create a medium which people can consume. You will create a higher one, but higher one will sell less. So data will never be distributed equally. Are we clear, everyone? Data will never. It always follows a trend. Trend is this one. So we can categorize this quality into two parts. Either you can say low or high, or you can say quality good or better. Good means 3, 4, 5. Better means more expensive, 6, 7, 8. Here we don't have 9 or 10. Sir, but with the ML be overfitted because mostly ML will be overfitted when we talk about 5 and 6. In the outlier one, we can remove these few things. If the data is very few. Are we clear? If the data is very few, or we can do the resampling one. We can do the resampling. Are we clear? That is a technique. That is a technique which we do to fix it. Currently, our type is we are doing the analysis. Is this part clear, everyone? Is this part clear? Okay. We have seen this particular warning a lot of the time. And to solve this particular warning, we just have to mention it is saying hue. We just need to mention hue to be the same component as our X, whatever is our contributing factor. Our quality is the contributing factor. Hue means just color. So for the color, if we do that, everything will be same, but that error will be gone. All right. Now, if you want to check the same thing, currently we are not able to see this count. Are we able to see this count? The quality value of 3 has how many counts? No. So this time we will check the summary of the count values. So for quality 3, we have 6. So actually this bar means 6. This 4 means 33. 5 means 483, 462, 143, and 16. Okay. Just another analysis which we are doing. Analysis does not have to be concluded, but to understand more about what this data is. If an ML engineer is starting with the data directly or the data numeric and trying to create a machine learning model, that person will never understand why a model is behaving certain way. Only when we do analysis and we train the model data as it is with the machine learning model, we also understand the behavior. If the output of 3 is kind of predicting incorrectly, then we know why. Are we able to understand? This is also the analysis, and we can predict how the model might be performing when it is trained with this kind of a data. Is everyone clear? Guys, are we clear? Only Dhaval is saying, others? Great. Okay. Next is, let's create a histogram to just check histogram for all the feature columns and see how the value looks like. All right. Just the histogram. So let's see. df.histogram, I want to separate in a bins of 15 for each. So guys, currently, am I plotting histogram for a single column or all my data frame? All my data frame, I'm plotting histogram, not a single column. So if I do df.histogram, it will plot for all the numerical ones and it will create the histogram for that. That's all. So it will create everything. See this. Fixed acidity, I'm able to see there are some patterns, but I'm able to see that alcohol percentage is kind of, what is this squid? What is the skewness of this? Positive. We always need to check where the tail is going. If tail is going the positive, it is positive squid. Okay. Yes, correct. Here we are able to see pH is majority of the pH we are able to see is around here, around 800 of the data set, more than 800. But okay, pH is there, alcohol quality is pretty well distributed. Not quality, this is density. Okay, this is not alcohol, this was total sulfur dioxide. Alcohol content is kind of is around good region. You can say although this 8% is very high, people know why 8 is high. All right. But we are able to see around 6, 8 all the way till 12 to 14. All right. How many of you are able to understand this alcohol graph? You can say so. Okay. Why it is around, no, why it is high around 8 or 9? Anyone can tell me? Why it is high around 8 or 9? Yes, correct. So majority, this is for wine actually, but for beer, if you check, majority of them are around 8%. Okay, percentage and others. So you are able to see that. But wine can get up to 14. Okay, wine can get up to 14 in normal circumstances. Okay, so quality also we are able to see the same thing, 4, 6, 8, 10, which we saw here. Same thing, but little spread. What are the axes? Axes are frequency. See this. This is with respect to the frequency. Here we will see frequency. Here we will see the numbers of that particular column. Vivek, are we clear? Frequency versus the numbers. So this one ID is pretty well distributed, but ID is something dummy. What we will do with ID? Shiv, don't worry about it right now. ID, we will drop it. Yes, ID is not of our use. ID, we will drop it. Okay. And remove it, drop it. We can drop it. See this. If this is df equals to df dot drop. In the bracket, we will mention, okay. In the bracket, we will mention what are the things which we need to drop. We want to drop, what is the exact column name? Let me check. df dot columns. It is nothing but capital I small d. Don't worry, no one has to understand or remember the code. df. What did I remove? ID is not found in the axis. Why it is not found on the axis? Why it is not found? Oh, I need to mention columns. Done. Better. Done. ID is removed. V class have few outliers. Yes, outliers and others are a part of engineering when we are going to remove it. But right now we're just checking that some data have this issue, some data have that. It is not an issue. This is how data is distributed. We cannot fix all the data to make all of them as normal because there are a lot of features. Machine learning will try to learn that. All right. But quality is kind of normally distributed and the mean is around 5, 6. We are also able to see alcohol. It is not normally, but it is not too skewed. All right. So let's try to learn about these features. And if you don't want this, and if you don't like this histogram or bar plot, we can always go for KD plots. But again, KD will provide you the density. And right now we are running the KD in a for loop. See this? For column in, and I'm dropping the quality because quality is something which you don't want to learn. Quality is our target. You want to learn everything else. Column, we're just plotting all the KD title and that's it. KD of fixed acidity, we are able to see the distribution, see this distribution, see this distribution. This one is KD of residual sugar. We are able to see that. So we can remove the outlier. I will talk about how to remove the outlier. All right. But outliers are present and we can remove it. Once we remove the outlier, then I think the problem will be solved. But depends on how many of the data we are removing. Guys, am I speaking some alien language or you are able to understand what I'm saying? Just like a podcast, I keep on speaking because there are a lot of things. Are you able to understand? Great. Thanks, Vijay. Okay. Just a KD if you want to see it. But later, as we don't have a lot of things to do here, I plotted histogram and I am currently plotting KD just for a smoother curve to understand. That's all. All right. So once the KD is done, now let's talk about the outlier itself. Now that we have outliers, why not do box plot? Yes, correct, Mohit. Outliers. Do we have outliers? We do have outliers. We do have outliers. And we were also able to see the outliers, right? Because it is not normally, we are able to see the lot of densities here, but very few values are present here. Sulfur dioxide, where is sulfur dioxide? Total sulfur dioxide is there. There are a lot of outlier, but outlier is always present. If this particular range, this IQR range is small, the outlier will also be dense because it is not too far as compared to this sulfur. All right. So this is contributing the graph itself. That's why we are able to see with respect to this, all of them kind of shrunk, right?